Based on the Department of Environment, industrial waste includes water, effluent, sawdust, and sludge from industrial plants. Chemical waste is defined as the transformation of waste and residues into valuable materials. The transformation of waste such as biomass, food, and industrials into fuels, energy, and other high value products plays an important role in green chemistry. Hence, industry are urged to develop and design a system to manage and reduce the waste from the manufactured products instead of dumping into landfill. This could improve the industry economically, and this economic system is known as circular economy.
Hello, I will be talking about challenges in research field. One of it is high cost. As an example, biofuel industry mainly in processing of biomass because processing of biomass are complex because of the structure of the biomass waste. Secondly, the cost of building and maintenance of the waste to energy plant. The next point is unsupportive government policies. Government doesn't make any policies which will create a demand in the market. The next point is ensuring the efficiency and less toxic consequences. As an example, by burning of waste can produce more harmful gases.
Next, I'll be explaining the two examples of research and innovation that are related to this field. These examples are using waste to produce useful materials, such as oil that contain hydrocarbon similar to crude oil, and a biodegradable high-resolution 3D printing resin. The first example was carried out on 2019, adapted from the research article from ACS Sustainable Chemistry and Engineering, where polypropylene is converted into oil by the aid of supercritical water at 425 degrees Celsius and 23 megapascal with the reaction time of 0.5 to 6 hours. A few further analyses are carried out from the oil obtained, and the oil obtained consists of olefin, paraffins, aromatic, and cyclic hydrocarbons. The second examples was carried out on 2019 based on the research articles from the SCS Sustainable Chemistry and Engineering, where waste cooking oil from McDonald in Toronto, Canada is converted into 3D printing resin. The waste cooking oil is converted into arcylated waste cooking oil via arcylation process and further purification, then followed by the characterization of arcylated waste cooking oil using NMR and FTIR. The study continued with 3D printing process and the characterization of 3D prints. To conclude, excellent resolution was observed using arcylated waste cooking oil.
So, we will be discussing a principle related to the innovation and example that was stated before. As for the use of supercritical water for the liquefaction process of propylene into oil, the first green chemistry principle related is waste prevention. Propylene has a very low market price and a very good processability which is extensively used for manufacturing various products such as plastic. However, due to its large consumption, a lot of waste was generated at the end of its life cycle. Therefore, the liquefaction process here favors the green chemistry principle by converting propylene into oil, which can prevent the production of waste. The second green chemistry principle achieved in the usage of supercritical water for the liquefaction process of propylene into oil is atom economy. Atom economy is defined as maximum incorporation of material used in the process into final product. This is done by the process of liquefaction using supercritical water to convert feedstock, which is propylene, into liquid product, which is oil. As for the second invention, conversion of McDonald waste cooking oil into biodegradable high-resolution 3D printing resin achieved waste prevention principle of green chemistry. This is due to the reuse of cooking oil to produce biodegradable high-resolution 3D printing resin. Besides, it also achieved the real-time pollution prevention principle of green chemistry. This principle is achieved due to the high biodegradability of the resin, whereas cooking oil usually takes a longer time to degrade. Therefore, it will slightly increase the pollution index toward environment. While the arsenicated waste cooking oil, the alcohol, has a high biodegradation rate which help in turning a problematic waste stream into a useful commodity and environmentally friendly over a longer time period. The last principle related to the production of biodegradable high-resolution 3D printing resin are designed for degradation. The high biodegradation rate of the resin is determined in the biodegradation test by calculating weight loss of sample after buried in the soil for 14 days. The arsenicated waste cooking oil alcohol recorded highest weight loss, which is due to the presence of bioavailable fats molecule or leftover from cooking, which give better access for the polymer network.
Hello. So today I will be presenting the importance and benefits of innovation of waste to chemicals. As we all know, innovation is very important in utilization of waste, not just chemicals, but many other products. This is by preventing the introduction of waste into environment and atmosphere. Besides, we can maximize resource production by using waste as the feedstock for new chemicals that mitigates the decreasing finite resources. Next is by design system properly by not neglecting life cycle thinking skill in innovation of waste to chemical. A proper physical and chemical design will produce valuable feedstock that comes from life cycle of waste material. As we all had know, innovation of waste to chemical have produced effective process, ideas, and product that benefits business and environment as well.
In conclusion, waste to chemical was proven to be the most effective in the waste management system, especially in industrial sector. Recently, the waste to chemicals becomes an interest to many industries to develop and design the system due to the positive outcome that could improve in terms of financial and production of the industry as well as its potential to secure the principle of green chemistry. However, there are few challenges that could delay the application of this system, mainly because of the cost and policy issues. Hence, it is an urgency to find the alternative ways to overcome the challenges in order to solve the waste management issues.